So I see one of the big duties for science and for the scientists to explain their approaches to the community, to the society, such that the society can understand and can enter the discussion with the scientists in terms of what society is ready to contribute, what society is ready to change.
Climate change certainly is the biggest challenge humanity as a whole has ever faced. Greenhouse gases, in particular carbon dioxide, are added to the atmosphere at ever-growing rates, trapping heat that would otherwise leave Earth into space. The increased amount of heat energy in the atmosphere intensifies weather conditions, making extreme droughts, floods, and storms more common. And they shift or disrupt local climates, with rainfall becoming unreliable, which impacts crop yields. This is in addition to the destruction of ecosystems like the oceans, which can lead to collapsing fish populations. Another major food source. Global warming melts glaciers in the mountains that used to be reliable sources of fresh water. The melting ice caps in the Arctic regions spill fresh water from land into the oceans, leading to rising sea levels. Shrinking coastal areas and growing deserts force large populations of people to abandon currently dense populated areas and move from severely impacted regions to regions that are less impacted. And this will likely cause tensions between peoples. We have faced a global air pollutant crisis before. In the 1990s, we stopped the production of CFCs, which led to the preservation of the ozone layer. It recovered within a decade or two. But CO2 remains in the atmosphere for centuries, and the warming effect is much slower and has a larger delay. In other words, the effects on the climate we see today are not the effects of today's greenhouse gas emissions. Every ton of CO2 we add to the atmosphere now adds to global warming for decades and centuries to come. This is why it is so difficult to instill a sense of urgency in the population. But this also means that every even small reduction in emissions rates can have a large effect on CO2 amount in the atmosphere in the future. At the same time, however, our economies are based on technologies that emit large amounts of carbon dioxide. Transitioning out of fossil fuel consumption means to change every aspect from electricity generation to the way we power our mobility and transport to the way our industries produce goods such as pharmaceuticals. International agreements to reduce carbon emissions go back to 1992. At that time, the necessary transition could have been smooth. But industrialized countries did little to develop and implement technologies that could replace greenhouse gas emissions. The latest installment of the Paris Agreement from 2016 was signed by 195 countries and declared the goal of limiting global warming to well below 2 centigrades above pre-industrial levels. But the latest report of the International Panel for Climate Change, IPCC, made clear that worldwide we are falling behind our own targets. Now, drastic measures need to be taken as soon as possible, meaning before 2030, in order to reach the targets. For this episode, I invited an expert for renewable technologies to talk about the transition to a carbon-neutral economy in Germany, the largest emitter of greenhouse gases in the European Union in total and per capita. As always, you will find a summary of this episode on our website www.scienceforprogress.eu. And if you are a patron, you can listen to the whole conversation on Patreon, www.patreon.com/sci4progress. By the way, in case you didn't know yet, I began releasing these extended episodes with a 7-month delay. To date, extended episodes 9 to 14 are available to the public. You can find the direct links in the respective show notes on our website. Just one more thing before we start this episode. Bart, my co-host, and I will do a live video session on July 2nd at 3 p.m. Central European Time on our Science for Progress YouTube channel. We will play a game where we read hilariously weird para- and pseudoscience stories. You can side with Bart or with me by sending your funniest story to either bart@scienceforprogress.eu or dennis@scienceforprogress.eu, respectively. We will randomly pick one submission and will send the contributor a Science for Progress t-shirt from our store. I'm your host Dennis Eckmeyer, and you are listening to episode 29 of the Science for Societal Progress podcast.
My name is Rüdiger Eichel. I am working part-time at the research center in Jülich and part-time at the RWTH University in Aachen in electrochemistry. My field of research is related to the transition of the energy system, Energiewende, how we call it in German. We are dealing with electrochemical energy storage, batteries, and electrochemical energy conversion, which means electrolysis, power to gas, power to X, power to fuels, all these type of concepts.
Following the IPCC report, something changed. Greta Thunberg took to the streets and triggered the Fridays for Future movement that is sweeping across the globe. Every Friday, students go on school strike to demonstrate for climate action.
I'm extremely overwhelmed by the impact of these Fridays for Future movement. It has enormously impacted the awareness. We just witnessed the European elections, and I'm extremely happy to see that climate change, all these issues about climate and our world, to my opinion, have been the most important issue at the elections.
During the discussion around Fridays for Future, German politicians said the students would not be able to understand the issues, and that we should hear the professionals. This triggered 25,000 scientists in German-speaking countries to sign their support for Fridays for Future. This was led by a group called Scientists for Future. And Rüdiger Eichel and his colleagues also signed the letter of support.
Yeah, we signed it, and I have many colleagues from Jülich who signed it. I personally couldn't be at the March for Scientists for the Future, but I know that many of my colleagues have been at this march. So for us scientists, it's really a beautiful situation now. So the society has lots of awareness. And if we come up with technical solutions, we have the opportunity that these technical solutions might really be realized. And yeah, this is a beautiful situation for us.
Many of you may have heard the name of the project to transition the German energy sector to renewable energy, Energiewende, a name that connotes the energy transition with a course correction and, at least to me, also has an optimistic association. The goal of the Energiewende is to achieve 80% of electricity to come from renewable sources by 2050. While at the same time leaving fossil fuels and nuclear power behind. But the Paris Agreement
goes a step further because it includes contributions not only from the energy sector, as described by the transition of the energy system, but it includes goals from other sectors as well, such as the mobility and transportation sector, the industry sectors, and so on and so forth. So if you like, to my opinion, the German Energiewende is a very important, very first step. But so we have to talk not only of transformation of the energy system, but also of a transformation of the industrial sector, of the mobility sector, and so on.
This means that Germany, one of the most industrialized countries in the world, with a population of 80 million people, ranking fourth in GDP worldwide behind the USA, China, and Japan, is setting out to reinvent its economy at its core. A challenge and a chance at the same time.
We have to think about completely new ways of industrial processes, which for a scientist is a beautiful situation. So it happens perhaps every 100 or 200 years that you can rethink and redesign processes. So this is why I feel at the moment in a beautiful situation. So you can come up with new ideas, and to my opinion, this is one of the best situations you can encounter as a scientist. So we can achieve a transformation of the industrial sector, and we can perhaps find solutions for industrial processes which are completely CO2 neutral. And then we really can achieve these goals to reduce the increased surface temperature by below 1.5 degrees centigrade.
Rüdiger Eichel is optimistic that we can achieve our goals. However, what has to happen first is a serious discussion within society about what we are willing to change and at what speed.
This transformation process will mean that everything has to be transformed. And so I see one of the big duties for science and for the scientists to explain their approaches to the community, to the society, such that the society can understand and can enter the discussion with the scientists in terms of what society is ready to contribute, what society is ready to change. So we might talk about a change in behaving. So the easy examples that you find in the news and the newspapers is perhaps reducing the amount of flights, perhaps reducing the availability of seasonal fruits all over the year. But we have to go deeper into this discussion. So in principle, if we want to have a transformation of many different sectors, and if we really want to do something valid for the climate, it means that we have to install much more renewables than we currently plan. But then we have to talk about where do we get these renewables from. So from a German perspective, Germany on the one hand side is a country that is at the forefront of installing renewables. But if we talk about how to feed these renewables into other sectors than the energy sectors, we would have to install perhaps twice as much renewables as we currently plan. Which means we have to, in the long run, Germany will be a country that has to import energy from renewables. And then we have to think about if we want to transform sectors like the industry sector, which are typically energy intense sectors, perhaps companies will move from Germany to other spots, which we call sweet spots of renewables. So these might be spots where there is much more wind or there's much more sun. And then it means that people might lose their jobs at the cost of jobs which will be generated at other parts of the world. And so we have to explain all these consequences to the society such that the society really will be empowered to contribute to the overall discussion. And this is what I believe is an important feature of what the scientists have to do towards the society. On the other hand, the society has to be willing to contribute to this discussion. And the society itself has to be open-minded and has to be ready to really, if we talk about Energiewende or transformation processes, it means that perhaps in the future life will be completely different as the current situation.
Well, life will also be different in the future if we don't act on the climate crisis, and those changes will probably be much less pleasant. But let's stick with renewable energy supply a bit longer before we look into ways to store energy from renewable sources in ways that other industries can make use of it, who can't rely on the power grid. Are the big central power suppliers in Germany working to achieve the goals in renewable energy production?
I feel that all these companies have understood. Some of them started their internal transformation process earlier than others. But to my opinion and what I understand in discussing with people from these EVUs is that they fully understand there is no way back to former times and they have to go forward, and renewables will be absolutely the future. So if we talk, for instance, of companies close to Jülich, currently they produce most of their electricity by coal gasification plants. But the future is, or they are ramping up their production of renewable plants. They are ramping up their wind farms. I think the only thing we might discuss is the velocity at which this transformation process can happen. And surely if we are arguing from a climate perspective, we have to be as fast as possible. If we are arguing from a perspective that we want to have a secure energy supply, most probably you have to argue with a different time frame. And if you are arguing as a function of company that has to earn money, the time scale might be different as well. So this is what I realize in the discussion. So there is no discussion about the goal itself. It's only a discussion about how to achieve this goal and how fast you will achieve this goal. And this is what I believe has to be explained to the society. And the society has to be explained why it can't be faster, why we can't do it tomorrow, or what has to be done, or at what price could we do it tomorrow. And this is a discussion we have to do. And to my opinion, we do not have to discuss about if we want to do it. We only have to discuss about how fast we will do it.
So the solution for the electricity producing sector is to build large amounts of new power plants. And Germany will probably have to import additional power to fuel all sectors of their economy.
So if you talk about the transportation sector, the mobility and transportation sector, we might talk about a completely electrified solution. So this might be a battery powered car. We might talk about hydrogen as a fuel. And then we might talk about fuel cell vehicles, and we might talk about synthetic fuels. All of this comes along with different efficiencies. So the big advantage of a battery is that this is a very highly efficient energy storage device, which means you typically get more than 90%, even 94, 95% of the electricity that you store in a lithium-ion battery, you get out when you discharge the battery.
Oh, that's pretty good.
This is really good.
Yeah.
So everything you get back. So this is not the case for a fuel cell.
In a hydrogen fuel cell, hydrogen is oxidized to generate electricity. This is different from fuel combustion engines, where fuel is oxidized in a controlled combustion to mechanically perform work.
So if you would produce hydrogen from electrolysis, then you can do it at an efficiency of, say, 60%. And then if you use the hydrogen to fuel a fuel cell, then this efficiency at the system level perhaps is at another 60%. So which means the overall process is at an efficiency of roughly 1/3. Which means for a fuel cell electric vehicle, you need to install 3 times more photovoltaic or wind turbine drives in order to drive the same distance as with a battery electric vehicle. So now with synthetic fuels, it's roughly the same story. So the advantage would be that you could use the already existing infrastructure of filling stations. You could use the infrastructure of combustion engines. You would have the advantage that with a synthetic fuel, the overall process of fuel production and fuel combustion is CO2 neutral if you would use CO2 as a starting chemical from a CO2 point source. for instance, from an industrial park or something. But the efficiency, or let's say the goal of a future combustion engine using a synthetic fuel is at perhaps 50%. And then again, so for the production of the fuel, the efficiency might be about 50% as well. And then we are even below the range of a hydrogen of a fuel cell car, which means for fuel cells and for synthetic fuel cars, we need much more renewable electricity than we would need for batteries. So the clear answer from that perspective would be battery is the solution to everything. So now the disadvantage of the battery is that the energy density itself is not as high as the one of a synthetic fuel of hydrogen.
With energy density, we mean that in order to store the same amount of energy, the battery has to be much bigger and heavier than synthetic fuel would be.
Which means that for some of the applications, so for heavy-duty traffic or for longer distances, with a battery, most probably you cannot do it. So therefore we will have synthetic fuels and we will need fuel cell vehicles in the future. So for long distance transportation or for heavy-duty transportation, I am pretty sure that for aviation in the future, there is no way around synthetic fuels, and for ships as well. So therefore we need all of it, but certainly we need much more renewables than we plan to install until 2050.
Did he just say there is an outlook on climate-neutral air travel?
Exactly. So the advantage of the synthetic fuels on the one hand side is that the synthetic fuel allows us to have tailor-made emissions. So there are synthetic fuels available where you can drastically reduce the NOx emissions and the CO2 emissions. And already now you would be able to use it as a blend, which means you could use this as an admixture to current diesel or to kerosene or to benzene, and you would significantly reduce the NOx and CO2 emissions. So therefore, I believe this is a very important direction to go, and it would directly help the climate, and we might think in the future of CO2 neutral aviation. Currently, if we produce these fuels, they cost about a factor between, say, 5 to 8 more than fossil fuels. So this again will tell the society we can do something. You would have to pay significantly more, but we hope that perhaps in 10 years we could reduce the price penalty to a factor of 2. And we have to discuss how we will deal with this. Currently, most of the people is talking about CO2 taxation. And this might be one of the solutions. So if we find a clever way of CO2 taxation, this might help these new CO2 neutral production technologies.
Dr. Eichel and his research institute are part of a larger research program to develop new technologies to use renewable energy for different purposes.
Yeah, we have a big project, and this is a national flagship project. It's called the Copernicus project, Power to X. And this Power to X exactly means power, so renewable energy, renewable electricity, and X might be gas, might be fuels, might be chemicals. So the idea is how to bring these renewables to many different sectors to help these sectors to meet their climate mitigation goals. And therefore we are working on novel technologies for electrolysis. So currently it's known that electrolysis can be used to split water, but we want to use electrolysis to activate CO2. So we want to use CO2 as a renewable feedstock. So there will be always CO2 sources in industry. For instance, cement will always produce CO2, but if we would catch this CO2 and we would use this CO2 as a building block for chemicals, then we could make something useful out of CO2. And this is what we believe would be or will be needed in a future circular economy. And then we can come up with CO2 neutral pharmaceuticals, cosmetica, or platform chemicals. So in principle, we could render all chemical industry in a CO2 neutral production process. And this would be our overall goal. And we are doing it step by step. But what we realize that many industrial companies are very much interested in these novel technologies. And we do not have to surpass any boundaries. Many companies are ready to really think about these new technologies, and some of them are even ready to invest into these novel technologies.
And how is that? Because then they have a resource that they can sell?
They have a resource that they can sell. And now we are coming back to Fridays for Future. The beautiful story is the awareness of a large, or I would even say of a majority of our community to climate issues. And the companies have realized if they can sell a product which is CO2 neutral, which is a green product, they believe that this will be an advantage over their competitor in the market. And to my opinion, this is a very helpful thinking of industry for our climate.
So how far has that come? Is it already in a stage where you could say maybe in 10 years we'll have it?
So we are working off the concepts. We are about to build up demonstrators. So which means demonstrators means we will try in small scales if this production is really possible, which means we cannot feed the mass market, but I personally believe we will have few products in 5 to 8 years on the market, but very small scales. But then one never knows how fast process is and how fast it can be scaled up. So I realize that many researchers are working on it, that also the research and development departments of the industry itself is working on it, which means there's a huge manpower behind. And I personally believe between 10 and 20 years, we will see a complete different market than we see it now. But I am skeptical that we can change something within 1 or 2 or 3 years. We would love to do so, but simply it's technologically it's impossible to scale it up that fast.
Another project they are working on are alternatives for lithium batteries. Germany has a lot of cars, and the goal is to soon replace every one of them with an electric vehicle. There is the problem that these are still so expensive that 80% of the population could currently not afford one. Not even talking about the lack of charging stations. While mandated mass production could bring the prices per car down, we are dealing with yet another problem: the availability of lithium for the currently used lithium-ion batteries. If the worldwide demand for lithium batteries goes up, lithium may become a rare element quickly.
So in principle, every product has its own life cycle, and for every product you have to think about a life cycle assessment, LCA, which means where does the raw materials come from, what does it cost to bring it to the plant, and what does it cost to process the material, and what emissions, CO2 emissions, energy is needed to do so. And this is why we thought about, let's think revolutionary. What would be the cheapest battery with the least carbon footprint? And then we thought, okay, let's start with really abundant materials. And this is why we have a concept where we start with silicon, with iron, with aluminum instead of lithium. And at the counter electrode, we simply take the oxygen from the air. So we work on a battery concept. It has not been developed or invented by us, but we are further developing it, where we have iron air batteries. So iron is a really abundant material. You find it everywhere in the earth crust, and you can easily process it. So it's not an energy intense way of processing iron. And therefore, we come up with a battery concept where we use an iron oxygen battery or a zinc oxygen or a silicon oxygen battery. And to our opinion, this is a very cheap energy source. The drawback of the iron oxygen battery, for instance, is that the overall efficiency, so charge-discharge, currently is in the order of 70%. So it's better than a fuel cell, but it's by far not that good than a lithium-ion battery. So the lithium-ion battery, we earlier said that the efficiency is in the order of above 90%. It's hard to beat. But you might think of using this battery concept as a very cheap battery. And so currently our battery survives more than 800 cycles. So this is what we believe is what a battery pack for a car would need over the lifetime of an electric vehicle. And so this is what we currently are investing in, how to scale up this technology. And car industry is concentrating on lithium-ion batteries, but you find other applications, for instance, novel drones. So perhaps in the future, the post might be delivered or the pizza might be delivered by a drone. And these metal air batteries are promising concepts for these drones because their energy density is higher than the one of lithium-ion batteries. And for these drone applications, energy density is a crucial parameter.
So couldn't that make up for the smaller efficiency because you have less weight to transport?
Exactly. You have less weight to transport. The battery is much cheaper. And so therefore the battery can carry heavier weight. So you can eat perhaps twice as much pizza with a given battery weight delivered. But you would have to install more renewables to recharge the battery as compared to a lithium-ion.
So these are all exciting news. New technologies are underway. And for scientists, it's like a science rush.
For us, it's a beautiful time. Sometimes I feel as being in the Klondike, so in this gold mining times when thousands of people were mining gold. For a researcher, it feels like this. So we will have the next decades of revolutionary technologies. And what's always the applause for a scientist is society has an interest in what we are doing.
However, compared to fossil fuels, which come out of the ground, basically ready to be burned, fuels from renewable sources will always be more expensive, where you can't use the electricity directly. Then they need to be used to charge batteries or fuel cells or produce synthetic liquid fuels and chemical resources from waste CO2. And because such processes are inherently not very efficient, this means Germany would need a lot more renewable power plants than they are currently planning to build. In fact, this year they are expecting to build fewer new wind turbines than they are taking down.
We can come up with many new and beautiful and helpful solutions, but we will need much more renewables installed. And then we have to talk about the backyard of the gardens of the people, which will mean most probably we will have more wind turbine drives close to the cities, and we will need more PV on the roofs of the houses.
For a summary and links for further readings and to the complete conversation on Patreon, find the show notes to this episode on www.scienceforprogress.eu. If you have questions, critique or suggestions, please get in contact by email info@scienceforprogress.eu or on social media @sci4progress for Twitter, Facebook and Instagram. And don't forget that you can win a t-shirt by sending your most hilarious pseudoscience story to bart@scienceforprogress.eu or dennis@scienceforprogress.eu. Please subscribe and rate this podcast on your podcast app and maybe write a review. I thank you very much for listening. Have a good day. Bye-bye.
So perhaps we should talk in 5 years again and see what happened then.
Yeah, absolutely. Yeah, thank you very much.
Okay, you're welcome. Bye.